Hey there! Today I want to show you how you can switch a remote control, which you normally activate and deactivate with a remote control, with your smartphone. For example here. So, let's start. You'll need a receiver module and a sender module of 433 MHz and a Raspberry Pi and some way of connecting these together. So let's start with the receiver so that we can read out the code the remote control sends. Therefore, I printed out this schematic so that we can see. So, on the back of mine is written that the right one, this one, is ground, and the left one is VCC, so the current, and this is going to be plugged in 3.3 volts, and the middle ones are just data ports. They are bridged, so it doesn't matter which one you'll use. So, as I said, connect this to 3.3 volts. The data port, you can use any GPIO port. I chose 20, that's this one, GPIO 20, and ground to ground. And now that is done, let's look into the software part.
The library we're going to use is called RC Switch, and to install that we need pip3, and this we install with the command sudo apt-get install python3 pip. Hit enter, then confirm that. And then we can install RC Switch, and the Python version is called RPI-RF. So now you have successfully installed it. You can, let's make a directory, remote socket. Then we go to that directory, remote socket. And now that is the GitHub page of the library. We are going to need the examples, which is receive and send, and there I'm just going to make a send.py. Yes, we can copy that like this and paste it. Then we save it and make the receive, which we're going to use. And yeah, I can't type, I've forgotten E there, sorry. We copy that like this and paste it into here, and again save it. And now let's look what codes our remote socket sends. So with Python 3 and receive the pi, you can start the program, and with -g you can specify the port. That's the port where your module is connected to, in my case 20. And you can see that there's already something receiving, but that's just noise, so just ignore it. And now start smashing a button on your remote control, and you see these numbers, and normally they should be the same, but in my case it's a repeating pattern of 4 different ones. So we need to further investigate in that.
So let's open up our remote control, because then we can see which chip is used, and that with that we gain further information. So open that up like so, and here we can see our chip, but unluckily there is nothing written upon. But I found a chip that might be this one in the internet. So let's look at that.
I think they used this one, the SI4010C2. This one has 7 connectors each side, and it is used for garage and gate door openers and wireless remote controls. But why is there now 4 different decimal numbers? That's the case because for the garage and gate door opener, they're using a rolling code.
The rolling code consists of several different codes for one on or off switch, for example, for channel A. In our case, it was 4 different codes. So what do you do? When you open your garage door, you push that button, and the code 1 is sent to the receiver here. So it's the receiver. And then the door opens. And the next time, the receiver expects code 2. Why is this the case? For example, there could be another receiver reading that code 1, and when I'm away, could open the garage door. That's a so-called replay attack. But that isn't possible because the receiver expects code 2, which the one who wants to open it doesn't know. So that's the rolling code. But in our particular case, the remote sockets don't care in which order the codes are, or if I only send code 1. So why do they implement this? I have no idea. If you have any, please leave it down in the comments. I guess that they had this chip already developed, and in order to save money, they made it like this, that they use that chip and the remote sockets accept several codes.
Because there is a lot of noise at the 3.3 volt version, you can plug it into the 5 volt pin. But I do not recommend this because most of the internet pages say that doesn't work, and it can destroy a port or the GPIO pin of the Raspberry Pi. But what it does, it decreases the noise to nothing. But again, I do not recommend it because it could destroy the Raspberry Pi. So again, we type in Python 3 receive pi and specify our pin to 20. And now I'm going to push the A on button And you can see this is much clearer. Not only these two are noise right now. So there you can see the cycle way better that were corrupt one. And yeah. But as I said, I do not recommend it.
Let's talk about the issue and why I do not recommend the code gathering. So the problem is that the GPIO input of the Raspberry Pi only accepts a max of 3.3 volts. If you plug that receiver to 5 volts, it is possible that this is greater than 3.3 volts. So if you see when I switch a little bit, it can go up to 3.4, 3.5 volts, and that could damage the Pi. So, but how is it possible to read the code then? Actually, you can use an Arduino if you have one laying around, and that is what I'm going to demonstrate you next. So, as I'm plugging it in, just quickly, why is an Arduino better for receiving the code than a Raspberry Pi? The Arduino does have runs with 5 volts, so the input pins do accept more than 5 volts. So there is no risk of damaging the input ports. So if you have an Arduino laying around, this is the better choice. And that goes into ground. So now let's look why it is so much better.
First, go to Tools, then look that is correct. Then you can install the library. As I said, it's called RC Switch. So you type in RC Switch, and then you can install that. And now you can open the examples, and this is better because in the Pi, as I showed you, you need to copy and paste it, and here it's just opening. So receive demo advanced, then here so receive on interrupt, that's 0. So on the Arduino that depends. For an Arduino Uno, that's pin 2, so connected to pin 2. And then you can upload the sketch and open the serial monitor when it's done. And now I am pushing the A on, as you heard. This is going on and off. And now you see these numbers, the repetition of the numbers, because there is almost no noise. So here the 104 is here again, and these 3 numbers do repeat again. And that's how I got to my Excel table, and that works way better than on the Raspberry Pi.
To do that, we need to change our receiver module to the sender module. The sender module actually can take up to 20 volts, but for the Raspberry Pi, use the 3.3 volts, because otherwise it won't start up if it's already plugged in. So our 3 volt is going to attach on the VCC, which is the middle pin. The data, the port GPIO 20, is connecting to data, which is the left one, and finally the ground is connected to ground. So now we try out what protocol our remote sockets are using.
So before we try that out, we want to look at what a protocol is. Here you can see that a protocol is defined with pulse length, sync bit, 0 bit, and one first bit. And here you can see actually how the protocols are defined. And for example, let's take the protocol 1. 350 is the pulse length. The sync bit means like that there's one high and 31 low pulses, so that the clock is configuring to the right timing. And that is one high pulse and 3 low pulses represents a 0 bit, and 3 high pulses and 1 low pulse represent the 1 bit. So now that we understood that, we can try out which protocol the remote sockets are using. So now we need our send program. So we're typing in Python 3 send.py, and now we can see which variables we can set. And for us, it's important to set the pin to 20, it depends, and the protocol we do not know, so we start at 1, and the code, that's one of the decimal numbers we wrote down earlier. So paste that and hit enter. As you can see, the remote socket doesn't activate, so 1 is not our protocol. Let's try out 2. That doesn't work either. Neither does 3. Now 4. Oh yeah, 4 works. Perfect. So let's try the 5 or 6 do work. No. This one was 6. Doesn't work. And I think the last one we saw was 7. No, it's an unknown protocol. So 4 is the only protocol that works. And now we can write down all the decimal codes and look at them. Here are the codes I found out for A, B, C, and D, and they all work perfectly fine. I tried it out with our little program. And just pay attention, I had a few issues. They aren't always correct because they're a little bit corrupt. So do push the A on button often so that you can see which decimal is the right one. So now most of the internet tutorials say that there's a pattern. So we can see here for our channel A, the last 4s are zeros. For the channel B, it's 0, 1, 0, 0. For C, it's 1, 1, 0, 0. And for D, it's 0, 0, 1, 0. And they all begin with 1, 0, 0, 1. And if they are an on or off decimal code, you can recognize if the 2 numbers before these 4 are either 2 1s or 2 0s, then it's on, or 1 1 and 1 0, then that's off. Only for D that changes. I don't know why. Maybe they just had a fault in the production there, but it doesn't matter. And now we can use these codes to write our web application so that we can use our smartphone to switch the remote on and off. To use the program, you need to install Flask. That is done with pip3 install Flask. So now that is installed, that's successfully installed, we can go to this program. This is going to be in the description, and here you need to modify the protocol which worked for you, your sender pin, and the decimal numbers you got from the receiver. And then you can start this program. And as you can see, it's running on the IP address. This you need to look up in your router. And then you can, as I showed you in the beginning, switch your remote controls on and off. Just pay attention that you do not forget the port number right there after you typed in the IP address of the Raspberry Pi. Now let's look at how to increase the range of the module.
For a 433 MHz module, it is recommended to use a wire of about 17 centimeters in length. Just plug it into the top right corner where there's a little hole, and then you can solder it onto there, and then your length, your distance covered, should be increased. That's all I got to tell you about this project. If you liked it, then hit the like button. If you disliked it, then hit that button. But please tell me what you disliked so that I can improve. Stay curious, and bye.